in order to test loudspeakers is equipment. And not only do we need to know what the speaker sounds like, but we have to be able to know its frequency responses, distortion, dispersion, power handling, total power output, and so forth. There's many, many things that go into making a good loudspeaker. And of course, the better your tools, the better you're going to be able to do your job. Now, one of the latest additions that we've had to our lab is a large anechoic chamber. Now, the anechoic chamber is an all-absorbing chamber. In other words, it absorbs 99.9% of the sound that comes from the loudspeaker. Absolutely no reflections, which we would have if we would test the speaker in an ordinary room. So this allows us then to have control conditions where we are not able to disturb the surroundings of the speaker like we might do in a listening room, where we might move a cabinet one day and cause a change in the response that we measure. Another thing that we would do in the chamber is to do time measurements. We can actually measure the arrival time from the various speakers and make adjustments. This is something relatively new in the industry. So let me show you what an anechoic chamber sounds like, or looks like. And we have a rather large isolation door here, which is very heavy. And inside you can see all the absorbing wedges. And each of these wedges is 45 inches long and has a cutoff frequency of 80 cycles. This means that above 80 cycles and way up to 20,000 cycles, we have all-absorbing walls. And below 80 cycles, the absorption gradually decreases. This is a tremendous increase in our measuring capability now that we did not have before. And we, as a matter of fact, two of the latest speakers that we've been working on now have been designed using this chamber, doing things that we were not able to do before. That now is some of the associated test equipment, which is located just outside the anechoic chamber. And the green equipment that you can see here is made by Brüel & Kjær of Denmark and is a world-renowned acoustic test equipment company. And we have purchased several pieces now totaling about $30,000 just for this equipment alone. And this is the only equipment that we can use to do certain tests in the chamber. And but now that we have the chamber, we can expand the B&K equipment and do even more tests that we were previously not able to do.
You're telling me about some additional test equipment you have, and one particular piece of equipment in particular that does measurements that actually show the story of what the loudspeaker does. And it has bar graphs listed or shown on the screen that tells the frequency response, and you can make distortion levels with a degree of accuracy that the human ear alone could never develop. Could you show that to us and tell us something about it?
Yes, that's our B&K real-time analyzer, and it cost us another $20,000 just for that. And with that, we can make instant measurements on speakers and sometimes settle the disputes about our listening tests, which we sometimes have. This is the Brüel & Kjær real-time analyzer, and what we're looking at on the screen is a plot of amplitude and frequency, the left-hand side being the lowest frequencies and the right-hand side being the highest frequencies. And you're seeing an instant frequency analysis of my voice, which is one of the many things, of course, that we can do with the real-time analyzer.
Roger, what is the frequency response of what we're seeing on the screen here?
Well, of course, at the very low end, we're seeing some background noise, which is the steady low amplitude things. And at the extreme right, we're seeing the input level to the analyze, which is not the one of the filters, but the total input level for the system.
What is the lowest frequency that we can read here?
Okay, we cover a frequency range of 12.5 cycles to 40,000 cycles. And this is normal in the wider than the normal range of hearing, but we find we need to know what goes on just at the extremes.
And I understand this is the device you use to measure the loudspeakers that you develop.
Yes, this is one of the other devices that we use to measure the loudspeakers to get more of a complete picture about what the speaker's doing.